Hmm. Hi, Professor. So, the title of our project is Mastering Chess and Shogi by Self-Play with a General Reinforcement Learning Program. Um, our team members are Sushma, Suman, Mahesh, Upendra, Vinay, Breno, Kavya, Jitendra, and Bharat. Um, Next slide. Yeah. Coming to our project, like we worked on the technical details. So how the neural network works, how the Monte Claro tree search works, uh, and MCT's TS technique is used to enhance the policy, um, and also how the reinforcement learning algorithm works. We also worked a lot on Markov decision process. So coming to the abstract. In the history of artificial intelligence, the game of chess has been the subject of greatest research. Shogi is a significantly harder game in terms of computational complexity, and the most effective systems use a combination of advanced search algorithms, domain-specific modifications, and handcrafted evaluation functions that have been developed over decades by human experts. Um, the AlphaZero algorithm is more common version of AlphaZero algorithm. It achieved remarkable achievement in the Go game, where it can learn by itself, called tabula rasa reinforcement learning. Um, we generalize this method in this paper into the single AlphaZero algorithm that can attain superhuman performance in a variety of tough disciplines. Um, AlphaZero algorithm attained a superhuman level performance in the games of chess and shogi, as well as Go, in less than 24 hours, despite having no domain knowledge other than the game rules. So here we consider 2016 Top Chess Engine Championship, World Champion Stockship, Deep Blue in learning the architecture that help us to perform such. So next, Bharat will continue. Yeah.
The motivation is going to say by the Mahesh.
Oh, uh, Mahesh will continue from the next slide.
Yeah, hello all. The motivation of the project come from the recent developments that had been made in the area of Mastering Go, where in which is in a two-player game. The Deep Blue is a chess playing expert system that has been developed by IBM to win the game of chess against the reigning world champion for the first time in the history. People find it interesting in event an algorithm that you can solve in Go language, which is a hard game compared to chess. So the first attempt to achieve this was by the AlphaGo program, which is used in deep neural networks and combine them with an advanced search tree, where the agent is trained using data from experts and professional player games and can beat the best human Go players. And after that, the next big achievement is the field is with the AlphaGo Zero program, the next version of Alpha Zero, where the agent is only provided with the game rules and trained with pure self-play reinforcement learning without any intervention of human knowledge. Then this program mainly uses in neural networks as it is the core, and we can also use it in Monte Carlo search tree for policy improvement. Coming to the next slide. To improve the chess issues, which uses a hill climbing search method, enhanced the quality of 100 out of 36 known problems marginally. And then after that, we extend these methods to chess and shogi in addition to Go, without any extra domain knowledge other than a game's rules, indicating that a general purpose reinforcement learning system reaches superhuman performance across a wide range of difficult domains. The choice of Drosophila is as the organism of choice for genetic study has far-reaching repercussions for the development of 20th century biology. The major difference between the two algorithms is the AlphaGo 0 calculates and optimizes the winning probability based on binary win or loss outcomes. And in this project, we develop MDP for chess and try to elucidate it by providing insights on the Monte Carlo tree search program in depth, which is the key to the Alpha Zero program. And coming to the related work, the improper of chess issues which uses a hill climbing search method enhanced the quality of 100 out of 36 known problems marginally. And we introduced a new model called Deep Improver for chess problems in this work by BLD and upgraded from the bounded depth first search is used in this model. The experiment which we can conducted on the identical questions revealed that the quality of 32 problems, which is about 89%, had increased. Furthermore, some of the enhancements are significant and stunning. The this has been regarded as a Drosophila of artificial intelligence by computer scientists in the mid 1960s. However, has greater importance for science and technology historical. And the Chinox is the most significant software advancement in the last 2 years has been an increase in its capacity to distinguish between drawing moves. Chinook stands out from the crowd by providing a value between the down prices in the range of +1 to +2. This strategy has resulted in several Drew games becoming winners in tournaments. In recent decades, a plethora of game-based learning methods has been produced. He employed the minimax search strategy, which Shannon proposed in 1950. It generalizes from zero to any value of the resultant new technique is proven to provide a feasible incremental and formulation of supervised linear regression as the extreme of one. Finally, it occurs as original and straightforward explanation of LSTD as a model-based reinforcement learning approach. At the National Institute of Radio Engineers Convention in New York, he initially introduced the notation of programming a computer for chessboard games. And the technical details will be continued by my team member. Thank you.
Hi. Now we are going to discuss about the technical details for this project. Yeah, like as we know, the chess is a very most popular game, which most of the members will play. And same as the chess, the Chicago is also one of the game, which looks like chess, but it's a 9x9 board. So like it is also same like chess. And so for this Chicago, we are going to use the AlphaZero algorithm. The AlphaZero algorithm is a computer-based programming developed by the Google DeepMind to the games for like chess and Chicago and Go, Shogi and Go. This algorithm was first described in 2016 by the David Silva et al. And there are the three main components in these algorithms. Those are neural network, Monte Carlo research, and reinforcement learning algorithm. When it comes to neural network, the neural network is used to generate a move for each position. So like the neural network is trained by self play. Like it will choose the directions itself. So like for each position, the neural network is used to move, and the move is then played against itself. So like the neural network, by using neural network, the game will be played by the both sides. The neural network is updated so that it is more likely to generate a move that leads to a win. So by using neural network, uh, we can win the game, and this algorithm is used to play against the human opponent, and shown successful in chess, shogi, and go. Yeah. And when it comes to Monte Carlo research algorithm, the Monte Carlo research is used to select the move which is most likely to lead to a win. And the Monte Carlo research paired with a deep neural network is used by Alpha Zero, which is used to iterate the policy. And Monte Carlo research starts at the root of the every tree and explores the whole tree by randomly selecting moves. And this algorithm then expands tree by adding the chain nodes to the selected moves, and then they use the neural network to evaluate the chain node. So this algorithm I also used to play against the human opponent. And then when you go to the reinforcement learning algorithm, the reinforcement learning algorithm is used to improve the neural network, and it will also update the neural network, which is more likely to generate a lead to a win. And this algorithm is used to train the neural network by self play. On for each position, the neural network is used to generate a move, and then it is played against itself. So then the neural network is updated. So it is more likely to generate a lead for a win. And this algorithm also used to play against the human opponent. So the next part is going to teach by Kavya. Hello, hello,
Yeah,
Kavya.
hello.
Yes.
Hi everyone. My name is Kavyasri. And moving on to the next topic is Markov decision process. And yeah, MDP can be used to find the optimal policy for a simple game like chess. And there are four possible actions for a player can take is up, down, right, and left. And moving on to the next slide. Uh, and the board size is 8 by 8, and there will be 8 into 8 combination for selecting a chess piece on the board. Yeah, for example, if the goal is to reach the opponent position, and it always takes 1, and the reward for all other states would be 0. And moving to the next slide, the discount factor is measure of how much future rewards are worth relative to the immediate rewards. And the discount factor 1 would mean that future rewards are just as important as immediate rewards. And 0 would mean that future rewards are not important at all. And moving to the next slide. This can be done by calculating the reward for each and every state and by choosing the action that leads to the highest expected reward. Yeah, thank you.
Hello, and the results we have obtained have been provided using a line graph. And the process uh, for obtaining results, what we have done is that the AlphaZero algorithm was put through 7 lakh stages of training. Hello ratings were calculated, and it has been presented in the bar graph. It's the following. First, we used Bayesian optimization to fine tune the hyperparameter of the AlphaZero AlphaGo Zero's algorithm despite the game specific tuning. And for each game, a distinct implementation of the AlphaZero algorithm was trained. 7,000 steps with 5,000 first generation TPUs have been used to develop self-pay games. And the following the results, in the game of chess, AlphaZero seems to be winning a lot when compared to the Stockfish while using the white keys. In Shogi 2, AlphaZero leads. Elmo seems to be leading while it's playing with the white, and even in the Go, AlphaZero is having the better results. So we have compared the three games: Shogi, Go, and chess, and we have done the AlphaZero's MCTS analysis also for the first most popular 12 starting steps of a chess, and we have compared the outcomes. AlphaZero analyzes only 80,000 moves per second in contrast to 70 million for Stockfish and 35 million for Elmo. So AlphaZero, on the next slide, this depicts what the first 12 moves are. We have only taken 4 moves for the presentation, and the next one is going to show us the comparison between AlphaZero and Stockfish and AlphaZero and Elmo. The next slide, please. So here we can observe that AlphaZero's against Elmo and Stockfish, and this has been taken as the result after 100 grams of training on the AlphaZero. So the primary variation can be seen here. AlphaZero and Stockfish's performance displayed against thinking time each move. Of 2 depicts each player's ability in terms of thinking time as measured on Elo scale in comparison to Stockfish or Elmo, who has 40 moves per second time to think. AlphaZero seems to be doing most of its emphasis on the best possible outcomes that we required. So we can conclude that AlphaZero is the algorithm that we have been looking, which can satisfy different games and provide the best possible outcomes. And the game of playing against computers and increasing the capability of computers to do an impeccable performance against humans is what we have made the paper made us to have interest in this. And many great scientists have tried to create clever algorithms so that solve the games to surpass human capabilities. And AlphaZero seems to be satisfying all the conditions that are required, and it has provided an excellent results in all 3 games. And especially with the Go, we obtained the first result with Go, and then we tried it on chess and Shogi, and it has proven with the best results. And the artificial intelligence require such type of algorithms to flourish for the future too. So this kind of information and this kind of research or the research gathering helps us to create a furthermore clever algorithms and contribute in different areas and to a different society. Thank you.